Three, two, one. Can you hear me now? Can you see me now? How's the signal strength here on top of Oroville Dam this morning using the Verizon network? This is a special live feed broadcast for Mrs. McCracken's fourth grade class in Nevada City, Deer Creek Elementary School in Nevada City, California, where normally on Fridays I volunteer for an hour to help with the math in the classroom. But we got another group of kids to meet here today to give a live presentation to at Oroville. So I'm unable to be in the classroom today, so I'm providing this live feed for Mrs. McCracken's fourth grade class at Deer Creek Elementary School. Is the signal okay? Is the signal strength all right? We're using the Verizon signal, so keep your comments clean today because the kids are watching. And this will just be a broad overview for the fourth grade class. So we're here at the Oroville Reservoir today. This is the Keystone Reservoir for the entire water system for Northern California. This reservoir and Shasta Reservoir are the two main reservoirs that provide water to the California aqueduct system that gets water all throughout the state of California, allowing California to be the fifth or sixth largest economy in the world and makes the Central Valley the breadbasket for the nation, or the breadbasket for the world, if you will. And the key is this Oroville Dam right here. The dam at Oroville has two main purposes. The first reason for the dam at Oroville is flood control. Before this dam was created, the Feather River would frequently flood out the Central Valley downstream. The second main reason for the Oroville Dam is to conserve water. Keep water in here so that we can use water all year long, and through a very complicated California aqueduct system, we can convey that water all the way down to Southern California. So this Oroville Dam is the tallest earth-filled dam in the nation at, over 770 feet tall earth-filled dam. And the Oroville Reservoir is the second largest reservoir in the state of California. So right now we're looking at a water level of about 805 feet. We haven't had a drop of rain here in February, and it looks like the weather's going to change and we're going to start getting some rain in March, and hopefully we can begin to fill this reservoir up. In order to control flooding, this reservoir has to be kept down to about, well, let me start with the top. The top of the reservoir is 901 feet. There, that's better. The dang phone tried to connect to the local Wi-Fi. Back on the air here. So you want to keep your water level down to about 840, 850 feet during the rainy season to provide flood control, because the primary reservoir for us here in California is the Sierra Nevada mountains, the snowfall in the Sierra Nevada mountains. That's our first reservoir. So the whole idea is to leave room in this reservoir to allow for the snow melt in the springtime to slowly fill this reservoir up and top it off. But right now we're at 800 feet. We're at our typical historic average right now, but we're about 40 feet below where we could be at this time of year. So the big question this year is, will we get enough rain to fill this reservoir up? Will we get enough snow in the mountains to melt and fill the reservoir up this year? We're at our historical average right now simply because we had a lot of rain last year. So we're in good shape due to last year's rainfall. That's what we're looking at in the reservoir today. So let me show you around a little bit of the structure here at Oroville. Let me flip the camera around if I can find the button. All right, so there's the Oroville Dam, 770 feet tall, but has an elevation of over about 920 foot of elevation. Now, way out there in the distance, can I zoom in? That is the sloped inlet structure for the power plant and for the outlet to Oroville. That structure is sloped to provide temperature control. Let me unzoom that. Come on now. Let me flip the camera back around. That'll force it to unzoom. To provide temperature control for the fish downstream. So that's the inlet structure that feeds the penstocks, which feeds a power plant located down below the dam. There's 6 turbines below the dam. That's a third function of this reservoir, is to provide electricity. Think of the reservoir as a giant battery, and the power plant gets to use that power. If you're just joining us, this is a live broadcast from Oroville. We're broadcasting for Mrs. McCracken's 4th grade class in Deer Creek Elementary School in Nevada City. This reservoir contains the entire Feather River watershed, thousands of square miles of watershed, 3 forks of the Feather River, north, south, and middle. All this water captures. Now over here is the backside of the gates to the spillway. This is the inlet to the spillway. So when the reservoir fills up to about 820 feet or so, this spillway is used to control the level of the reservoir, in addition to the water flowing out of the Hyatt power plant. There's a pair of gates located right down in here that allows the water to escape. I'll show you the spillway over here in a minute. And this is the backside of the emergency spillway, located at 901 foot elevation. Has only been used once in its lifetime, and it didn't work very well. We'll talk about that in a minute. And it's been completely rebuilt. So the emergency spillway is a non-gated structure. The water just flows over the lip of the emergency spillway. So now let's go see if we can get a better view of the main spillway and the emergency spillway over here. Walking across the dam. There's still construction going on here today. Now, right down here is the control for the gates. Here's an access road over the spillway, and here is the main spillway to Oroville, all recently rebuilt since it failed 3 years ago during the heavy rains of 2017. That spillway is 3,000 feet long and 178 feet wide. That spillway is capable of flowing 150,000 cubic feet per second water downstream. That's the maximum amount of water you want to flow down that spillway to avoid flooding folks down below. Next to the main spillway here is the emergency spillway. This has all been reconstructed using roller compacted concrete and a stair-step design pattern, including a secant cutoff wall at the base of this spillway, where the water will eventually just spill out onto the dirt and down into the forebay down below. Way off in the distance is the afterbay and the Feather River, where this water eventually flows to. So that's the basic overview of the Oroville Dam and Spillway for Mrs. McCracken's 4th grade class. This structure is very important because it provides water for the entire state of California. This and Shasta are the 2 main reservoirs in Northern California that do that function. And of course, this dam and spillway structure also provides flood protection for the folks downstream. Back in 2017, this spillway failed right down here, and operators nearly lost control of this reservoir and were forced to use the emergency spillway over here. Briefly, that emergency spillway began to erode. That erosion started working its way back towards the emergency spillway weir, which resulted in the evacuation of over 180,000 people and a very scary and sudden evacuation of folks from the Oroville area and downstream. The water level was able to get, well, barely controlled. The weather relented just enough to where the emergency spillway stopped pouring over and folks were able to come back from the evacuation, and a massive $1.1 billion rebuild project commenced on this Oroville main spillway and emergency spillway and was completed in just 2 years. A 10-year-long project getting done in just 2 years at a cost of $1.1 billion. And breaking news for the Blanco Lirio fans, FEMA has approved the 75% amount that they typically do for disaster funding disasters, and they are going to eventually fund 75% of that $1.1 billion here at Oroville. It comes in a series of payments, but it has been officially approved. So that's the latest from Oroville. We need some more rain. We got some rain coming. Get this water level back up, and we'll see if we can fill this reservoir back up again this spring with enough snow in the Sierras. So I got to go meet another group of students here this morning and give them the same briefing. In fact, I think I see them right over here now. Say bye-bye to Mrs. McCracken's 4th grade class. We'll see you next week. We'll see you here. Where'd they put the off button?